Hello everyone, welcome back to another video. My name is Jared Beckwith. I'm an EEG technologist, and in today's video, I want to talk about some advice for medical professionals who are also interested in artificial intelligence. So I was watching this Stanford lecture by Professor Andrew Ng, and he was talking about some advice he would give to radiology students or doctors who are also interested in AI. Now, he's the man to listen to, so I'm gonna run this short clip and then I'll give my thoughts about it.
So I sometimes talk to doctors, radiology students, including like Stanford and other universities' radiology students that want to learn about machine learning, right? Because they hear about deep learning maybe someday affecting radiologist jobs, and so they want to be part of deep learning. And so my career advice to them is usually to not forget everything they learned as a doctor and try to do machine learning 101 from scratch and just forget everything they learned as a doctor and just become a CS major. I think that path can work, but I think where a radiologist could do the most unique work that allows them to make the most unique contribution is that they use their domain knowledge of healthcare and radiology and do something in machine learning applied to radiology.
So what Andrew Ng said in his video is that the most important thing as a healthcare professional is to not underestimate your domain knowledge. Now, that pretty much just means like whatever your specialty is, don't underestimate all that knowledge that you've accumulated working in the hospital day in and day out, whether you're just a radiology technician or an actual doctor. Your domain knowledge is very important. You can't just take a bunch of machine learning individuals who work at like Facebook, Google, Apple, and just put them in a room and tell them, yeah, make AI for healthcare. They're not going to be able to do it because they don't know the intricacies of your specific domain, whether that happens to be EEG like myself, where we record the patient's brain activity, the electrical brain activity with a bunch of wires, or if it's an X-ray tech, or let's say you're a dermatologist and you look at people's skin for skin cancer or something like that. Your domain knowledge is very important to creating an artificial intelligence algorithm that will help classify these radiology images or scans. So there's many different subfields of machine learning. You got reinforcement learning, unsupervised learning, you got supervised learning. And so what do you look into if you're a medical professional and you want to do artificial intelligence to label or classify medical images? Well, you're just going to want to go with supervised learning and forget all the other stuff. This is going to be where most progress in industry right now and in the field of artificial intelligence, it's done through supervised learning. So let me give you the basics of that. Let's go with the example of a handwritten digit image data set. Let's say you have 10,000 pictures of handwritten digits and you want to train a neural network to classify these handwritten digits. So you have your digits 0 through 9. You have 1,000 images of each. You have a picture of the 0 with a label of 0. You have a picture of a 1 with a label of 1. Over and over again, you have a bunch of pictures with labels telling the computer what it is, and this is going to be called your training set. So in our training set of handwritten digits, we want our computer to see all the different types of handwritten digits it could run into. So you have people who write their 2s like this. You got people who write their 2s with a loop in them. You got people who write their 4s like this. You got people who write their 4s like this, kind of like a triangle. So in order for our computer to recognize all these different ways of handwritten digits being written, we want to include all those different types of examples. Now, relating that back to medical imaging, you're going to want to include in your training set all different types of the medical images that you want your computer to be able to recognize. If you leave anything out, for example, in my field of EEG, we use EEG to detect seizures. If I leave out any kind of specific seizures or spike that I want it to detect, if I don't give it any of these training examples, it will not learn to recognize those patterns. Let's say you're a dermatologist and you want to make an app where you can take a picture on your phone of your skin and the computer will automatically determine whether it's any type of skin cancer or if it's normal and just benign. In order to do that, compared to our example of handwritten digits, building that training set, you're going to need a bunch of pictures of different skin cancers and you're going to have to hand label those pictures So there's going to be this type of skin cancer and you'll give a label. There'll be this type of skin cancer, you give a label, and you're going to want to include all the different types of skin cancers that could be popping up on people's skin. And as a dermatologist using your domain knowledge, you will know that better than anyone else, and you'll also be able to provide the labels if you're a trained doctor. Now, if you're a new doctor, you may make some mistakes in labeling some of these skin cancer images that you feed your neural network, which isn't good. So if you're a brand new resident doctor and you're the one providing all these training data set labels, all the labels for all the different types of skin cancer that you're going to feed your neural network, it's probably never going to outperform a single doctor. And the reason for that is, since you're a new doctor, you're inevitably going to be teaching the neural network wrong things, because it just takes what you say 100%. It doesn't question you at all. But if you're a doctor who's been doing this for 30 years and you've seen all different types of skin cancers, just that much experience, and you're a lot better than a new doctor, and you're the one who's providing the data, the training labels, you could outperform a single doctor with your algorithm. But it's going to take tens of thousands of labeled images, and a doctor with that much expertise, they're very busy, you know? Another way to do this would be to crowdsource the annotations. Let's say you have a team of just regular doctors who have been doing it for some years, but they're not like 30 years in. Let's say you have a team of those doctors looking at all the training data images and labeling them by debating amongst themselves, deciding on which label they all agree on to place on the image. Now, doing that, a team of regular doctors could probably outperform that single doctor who's been doing it for 30 years, and definitely outperform the new single resident doctor. So that's another way around it. So when you're feeding your neural network its training data, you really have to think about, what am I feeding it, and am I feeding it the right information? And how can I give it the best information possible and the most information possible? You don't want to leave out any examples of skin cancer in this example, because it won't be able to detect it if it's never seen it before. We have to supervise its learning, hence supervised learning. We are the ones, as the medical professionals, giving the domain knowledge to the algorithm. We are supervising its learning. Once you have your big training data set of images, well, what neural network are you going to use? Well, in the case of image classification, you're definitely going to want to use something called a convolutional neural network, or CNN. That's what you're going to want to use. So in these neural networks, you have what is called a receptive field, and it will slide across your image back and forth, and it will pick up different features of the images and correctly classify your images. So if you're wondering what the images look like to a computer, it's just a two-dimensional array, just like a box of numbers. And the totally black ones will be 0, and the totally white ones will be 255, and anything in between is between 0 and 255, depending on the level of darkness. While your neural network goes through all these training dataset images, there's this thing called an optimizer, which will optimize your neural network's performance, change these things that are called weights, and hopefully get you to near 100% accuracy of your classification of your medical images. Just because your algorithm does 99% on your training dataset doesn't necessarily mean that your algorithm will generalize to the real world. So you also want to have what is called a test dataset, which your neural network has never seen before, and it is a totally new set of images. That's what you actually do the real test on, to see if it can generalize or if it just overfit your training data set. If you got really good performance on your training set but not on your test set, there's a couple things you can do called regularization. You can either do something called dropout, which turns off randomly different nodes in the neural network. That can sometimes help. There's also this thing called early stopping. You just stop the training early, and you can also just add more training data images. That can help as well. But that's pretty much it. Me and my friend Casper here, the cat, we're pretty much done with this video. That'll just give you a pretty much foundations of what the heck this machine learning thing is and how you as a medical professional can get involved in it. Just focus on your domain knowledge, find someone to partner with who can do the actual coding, and you guys will go far And that's what I'm doing in my life, and I hope you guys can apply that into yours as well. So make sure you hit the like button. If you have any comments, just leave them down below. I love to talk to you guys, and I'll see you guys on the next one.